Hi everyone, I'm going to talk about the model or the project that we are working on for supply chain, and this deals with uh, a model creation to help predict issues or delays that occur during the supply chain process from order creation to delivery and invoicing. Right. So in the attached uh, process flow, you can see once an opportunity is received by our company, we go ahead and create the quote and order. Post that, it goes into manufacturing. Once the manufacturing is completed, and it goes for delivery using our logistics uh, systems, both road and rail, etc. Once the customer receives that delivery, invoicing happens. Now, there is an opportunity in this scenario because there are a lot of times when the date that we commit to the customer, we either deliver before or after that date. So both uh, scenarios is a problem because the customer needs to be ready to receive that delivery, which will not be possible if it's delivered before time. And if it's delivered after time, even then it causes a lot of frustration on the customer end, right? So there is definitely an opportunity, and this problem needs to be addressed, which is basically missed commit dates and invoice, which leads to invoicing delays also. Uh, can machine learning help? Yes, definitely. We will use machine learning to be able to predict the exact root causes by classification, as well as it can also help us in identifying what could be, the ETAs of materials being available, manufacturing being able to complete its process, all of that, and highlight where the delays are happening and which could basically shift out the ETA for the customer. It is a high priority for the leadership because it impacts a lot of revenue because of invoicing delays. Now, to understand this end-to-end process, what we have is we've done the business understanding. We have a huge amount of orders that are basically with along with order creation dates and other data attributes that we have gone ahead and met the SMEs and understood the data, how it flows from opportunity, quote, and order to when it's in manufacturing, what flags we need to use, and once it moves to delivery and logistics, what would be the indicators for our model to be trained on and the invoicing date. So to help our model effectively predict how the material comes in or how the dates impact by order categories. We have done that data understanding and also prepared the data for our um, model training. Right. Once that this is done and the modeling, the algorithms, all of that has been set up, we will also do the evaluation, which will be continuous cycles of running through all of these steps through opportunity to invoicing business process and ensuring that we are able to identify outliers or any data drifts over a period of time. Also, if there is process changes, how do we take those into account, right? So training schedule, model training schedule, all of that, right? And then we go ahead and deploy it. So we'll have one deployed model and one challenger model at any point of time. Now, the next important thing is the success outcome, right? So on successful implementation of the model, we should be able to correctly predict and also trigger a response from the leadership to take corrective actions uh, to identify and mitigate the cause of order delays. The outcome would be the output would be a metric would be a drop in the overall delays or uh, non-predictable dates of delivery, the actual date of delivery should be the same in ideal scenario, or should be able to match to what the model is predicting. Once this is done, the next important thing is validation plan. So we would use the k-fold cross validation here. It is widely used and highly accurate method. We would divide the data that we have into 6 or more sets of data, and then iteratively use those, some for training, some for testing alternately. This will help us eliminate any bias, as well as ensures that every and all type of data also gets tested and trained, right? So this will be done iteratively. Also, new data, when it arrives, we will follow the same process, so that in future as well, when we are retraining or doing any updates for models as well, we'll be able to have a standard validation plan. Now, coming to the system design for this particular model, we will need an edge system to make sure that all of our data, as well as the confidentiality related to invoicing, pricing, all of that stays on, and it doesn't go on cloud, it remains on the edge servers. We will opt for the offline learning and batch predictions, because we don't need the learnings and predictions real time. These would be done once a month to train as well as to predict uh, what type of orders are coming up, right? Um, Potential risks in production. We can have issues where we might have an problem with the data for training or production. Data latency could lead to stale data, which can give incorrect predictions. Data drift can happen as well in this scenario. And then concept. So in case the underlying process or the logic itself of the model needs to be changed or is not relevant, then probably could also be a potential risk in production long term. So that's the overall plan of the model, as well as deployment of the model and making it successful. Thank you.